Hey Ryan,
Hey Dan, how's it going?
we're destroying the fourth floor right now and cleaning it out and pulling the carpets up and moving all that stuff down. So it's getting clean up there. Hey
That's
Ryan,
all
how's it going?
good. How are you doing?
Too bad, not too bad.
Oh,
I'll
good.
slack you right now the credentials.
Perfect. Oh, good. And I see some people joining right now.
That's perfect. Yeah, I know it's a great. I mean, we can answer questions, I guess, ahead of time if anyone has any. All right, your fields. Here we go. Settings.
You can do it. That'd be pretty cool.
Okay.
Do it, I dare you.
All right, Ryan, here's the email in Slack. And here is the password.
Yeah.
Use that to sign in and tell me if it works.
Hello, my name is Owen.
Hi, Owen.
I'm a TOHacks exec moderating this session. I'm just letting you know that if you have any questions, you can just ask for me and I'll be quick to respond to any questions.
Well, thanks, Owen. You rock. How's everyone else doing here?
Do you have any questions about how to run this session?
No. I think we'll just say hi and ask people to ask questions as required. There was a great turnout yesterday, actually, to the pre-workshop.
Cool. Do you want me to introduce you or you introduce yourself?
I'm happy to introduce us and everything.
Okay, that's cool.
I'm gonna switch off because I'm.
There's a lot of noise. There's a lot of noise coming in from someone right now. Well, that's you, Ryan.
That's me?
Oh yeah, there's some. Oh, okay, it's gone now. It's all good. Did it work? Did the sign in work? Cool. So then if you click on the, obviously the little icon top right and you click on your fiddles, you'll see them all.
Great. Are you ready to get started then?
Well, we're technically 5 minutes early and there's people starting to join. Oh, wow. Hi, everyone. There were 3 and now all of a sudden there are 32. Hey, while waiting, so we got 4 minutes rather than just, spend it in silence. I'd love to hear from Molly, a little bit about you and what your interests are, what type of coding, where you're from, anything you want to say.
Hi. So my name is Molly Liu, and I'm from University of Waterloo, and this is actually not my first time of hackathon. I'm kind of interested to see what TOHacks will bring my team to. And I'm really interested in DCP to learn about what this is all about and how can I best utilize the tool to say help build an app. And I'm just generally very excited to see what DCP
He
can
asked you
offer.
for thoughts?
That's cool,
No
Mike.
way.
What was that, Andy?
Andy.
What was that, Andy? You're live. All right. No, that's cool, Molly. Thanks. That's really cool. Did you see yesterday's quick presentation that we made, sort of like a sneak peek under the hood, or is this the first?
I checked out the website actually,
Okay,
but then I was trying to, yeah, because it was quite a new concept for me. So I'm just trying to grasp like what's it's about. So yeah.
Yeah, for sure. So just personally, I'm a physicist. So I went to Queens and I did my PhD there, and I needed a lot of computers to do a lot of computing. It would sometimes take like afternoons or even days, like to do some of the simulations for computational electromagnetics, like levitation and propulsion type stuff. But I mean, the application doesn't matter. And it was a real pain in the ass, to be able to do that compute. Like if using the tool sets, I'd have to like go to every single computer and install, let's say, MATLAB or Maple, and then set up all the grid toolboxes. And like it wasn't worth it. I just press go on my laptop and let it fry for an afternoon, because it wasn't even worth like the rest of the effort. And I certainly didn't have the money as a student or whatnot to go to AWS and spend a fortune on commercial cloud, especially if you don't even know what you're going to do is going to be worth it in the first place. So that's it. So fast forward 2.5 years, and what we've built is something that makes it stupid easy, as Ryan will demo later, to take your code and like build literally anything you want and spread it over phones, fridges, enterprise servers, computers, desktops, all with like I think 1 or 2 lines of code. So that's what's cool about this. And now on top of that, we built a bank. So people could literally get paid for letting their computers do work for a giant grid. It's kind of like electricity. Normally people buy electricity, but if you hook up solar panels to your roof, you can actually sell excess back to the grid. So that's what we've built here with DCP. It's sort of like a sharing economy of computing power. Sidhu, I'd love to hear about who you are and where you're from and what you do.
Hello, my name is Sidhu, and I'm a first-year student at McMaster Computer Science. I'm really glad to be here today. I just joined this. We got the notification, and and it looked somewhat interesting. I'm still pretty new to like computer science and all this kind of stuff, so I'm just in this hackathon browsing through these various workshops and just trying to see if there's anything that interests me.
Yeah. Well, welcome to the dark side. All right, it's 2 o'clock. We'll get started. I see we have 71 people on the line, 72. This is awesome. Okay, so for those who just joined, my name is Dan. I'm the Executive Director of Distributed Compute Labs. It is an educational nonprofit here in Canada. And we are rolling out DCP for free to universities, high schools, and educational and student groups across the country, maybe the world, for free. And then, of course, we have a for-profit that works with commercial enterprise and monetizes it through those more for-profit-y type activities. But for students and researchers, we're making it free. In a nutshell, it's a software platform that cloudifies anything and makes it work for you. You can spread your compute around, or you can even use it to make some extra bucks on the side when you're not using your computers. So on that, I'd like to turn the mic over to Ryan, who's one of our exceptional programmers on our team. And he actually participated in a hackathon much like this about 1.5 years ago. And he used DCP back when it was like really hacky and we were still building it, because we're still a startup, right? Trying to do something cool. And he made a distributed fractal rendering application. So that was his app. He used DCP to spread around a bunch of computational fractals. And he won the Mayor's Innovation Challenge. And then he walked into our office a couple of weeks later and said, "You're going to hire me." And we said, "When do you want to start?" And so we're honored to have him on the team. And we're happy to be today co-sponsoring this event and offering a $500 cash prize for essentially just the coolest thing that someone could build and launch on DCP as a proof of concept. Now, before I turn the floor over, you're getting the pre access to this platform. It's not finished yet. It's still very much a hack in its own right. And we're just spreading around to people to let us know what they think and try and do stuff with it. And we're actually preparing to launch the product within the next couple of weeks. So you'll most likely run into some bugs and all kinds of stuff. Let us know, we'll fix them, we'll be grateful, and we'll make it even better. So that's it. I digress. My name's Dan. If you have any questions, let me know. Ryan, over to you.
Great. Thanks for the intro, Dan. Hey, everyone. I'm Ryan. As Dan was saying, I used DCP for a hackathon last year. It was TOHacks. And it was so easy to use that we ended up building our fractal rendering in that weekend and presenting it, and it worked great. And now I'm here. So I'll give you a bit of a demo on how you can use it for your own projects if you're interested. I have a few JS fiddles.
Some sort of like scheduler for.
Sorry, did someone have a question?
Yeah, so no, that was good. Someone was asking about a scheduler, and they're absolutely right. There are three pieces essentially in the software platform. There are the clients that essentially deploy work, and you'll see that. Then there's a scheduler in between, which you don't even have to worry about. And then there are workers. And so interestingly, clients can also be workers, but so can all their friends and everything else. So you could literally run around your house right now, open these the worker fiddles, and turn your whole house into a computing network that would essentially do your computations. But sorry, back over to you, Ryan.
Yeah, I'll give a little run through through that right now. So we have our one JS package.
It's echoing on my side.
Sorry. You can use our one JS package. Right now, we're serving it just from our scheduler. This will eventually be on NPM. You'll be able to use it on node scripts. But inside this fiddle, all you need is the script tag to request our client library. And then this is all the code you need to deploy work to our network. You use our compute API. And then you can use our compute for function. So this will take this function here. It could be anything. And it'll run it however many times you want. And it'll distribute that function to any number of workers. So in this case, we're running it on like a for loop, 0 through 99. We're saying run this function 100 times. And each time we're going to return just a function of cosine based on the input value. Now, obviously, this could be anything. For distributed tasks, you'll want something that's more computationally intensive, so it's worthwhile splitting up. But once you create your job, you can then just call exec on it, and you set the price that you're willing to pay for running that job on the network. And then that'll get handed out to all the workers on the network. It could be servers, fridges, phones, whatever you have. It could be your computer. So this is what shows up. When you load this in the web, a modal pops up prompting you to provide your bank key store. I have one on my desktop here. Then mine has a password. And just like that, your job gets deployed to the network. I think this one logs to the console. So you see that we're receiving status events from the scheduler. There are 100 total slices that we handed out, and this keeps track of how many we've distributed. And then as we get them back, you see that the computed value increases. So it's working, we're receiving slices back from all the workers, and it'll be done right now. And then we get all our results back.
Thank you.
Just like that. So it'll just be a bunch of cosine numbers for now. You can also hook up to more events. Obviously, you want something more sophisticated for showing it to judges or whatnot. So I'll provide my key store. This is a similar demo.
And just so everyone knows, these credits that are moving back and forth on the network, it's a digital unit of account. You can earn them by doing work for the network, and then you spend them when you deploy work to the network. So if you let your computer compute for 10 hours, you can then do approximately 10 hours worth of compute with everyone else's stuff, but all at once. So it's sort of like, it's literally an economy of computing power. In the same way that you have kilowatt hours to sort of measure electricity consumption and also electricity provision, we use these computing credits as a unit of computing. It's approximately 1 credit's like 14 CPU hours or 1 GPU hour, but there's also bandwidth and reputation and memory and other things like that. But we won't get into that right now. Just think of it as a bit of a bank or some sort of digital coin or something.
Yeah, exactly. For the purposes of your project, I believe, Dan, you've sent out a key store that everyone can use that already has DCZs in it. You can use for your projects. This is just another example, same function as last time, but we've hooked up a few more events here, so you can listen to results as they come back. You can print them out to the console or use them, or whatever your application needs. Now on the other side, not only can you deploy work, but there needs to be some computers that can do the work as well. So this JS Fiddle has an example of starting using your browser as a DCP worker to earn credits. So once again, we load DCP client, and then all you need is one line. And this will boot up web workers. This will fetch work from the scheduler, and your bank account, you can provide it here, will get paid for doing that work. So if I just run, it's doing it in the background. I'm sure if I went to my application here, there'd be some web workers spun up. So they're doing work in the background. You see, I said I want 4 cores working. We have 4 sandboxes, and obviously you can hook up some events to this, so you can provide a more user-friendly interface as required. And that's the basics of it. It's really easy to use. You could make this function do anything. It's just JavaScript, and it'll run on any device. Does anyone have any questions?
No, that's awesome, Ryan. Thanks. What I'd like to do, if you can stop sharing your screen for a second, I'll show what a sort of like a polished, example could look like. So I'm not a master developer like Ryan, so I got a lot of help building this one. Let me share my screen and I'll show you what you can do as an example. This is one of the demos that we often do. Ryan, I'm just going to put you on mute. All right. All right. So here's something that we made with DCP. So it's just a simple website, and we decided to make it look like a scientific paper. Manuscript, which all of you're all out of or in school or graduates or whatnot, so you've seen a million of these papers. But this one's different because it's live, it's in a browser, and it can be interactive. So this actually is my own research from some time ago, and it's what I was running on my laptop and taking like entire afternoons to render solution sets. But what's cool here is that as the reader, you can actually modify the input. So actually, I'm going to do a couple of these. We're going to create 4 force curves, and let's say I'm going to do a high enough resolution. I'm going to send this off for computations. As soon as I hit compute, nothing's going to happen because we have no workers hooked up. Today, you will all be the workers. So there's compute. Now I invite you all on any device you have lying around, phone, tablet, computer, laptop, whatever you have next to you, open a browser tab and type in dcp.mn. dcp.mn. You'll see this. Say, oh, not dcp.org. dcp.mn. This is what you should see. And as soon as you see it, hit start, and your computer will instantly join a computing network. It'll accept tasks, and the processors on your computer are doing my physics work. So right now, for those who've done that, see the bar is moving even faster. The more of you that join this network, the more computers suddenly become part of this instant compute network. And so together, we're all doing computational electromagnetics. The results are coming back to my computer right now, and when it's finished, they'll display. So think of the cool hack you could build, where the judges will, essentially come to you and you say, check this out, and then you say, pull your phones out, and then they have to type in, a URL, and they instantly join a compute cluster that power your app. It could be distributed blockchain, distributed chemistry, astrophysics, really literally anything you can think of. Imagine distributing like unit tests or stuff like that. So you can get quite creative with this stuff. Let's see. For chats. Are there any questions so far? Oh, I see. Andy says, I think I get it now. DCP.MN, very cool. This is so cool. Yeah. So somewhere there's a few tasks left, and when they complete, they'll all come back. And there we go. So normally this would take a lot of time, like many minutes for the number of computations. But with our, I don't know, 50 or 100 computers, whoever's on the line, it made it go a lot faster because we essentially divided up the work. Now that's just the beginning. Here's a a blockchain style one. We're distributing essentially just simple. It's just a hashing function that we do a million times in the background, but we can essentially spread this around to as many devices as connect. Even more cool, this is in my wheelhouse because it's more physics stuff. We built this for US Department of Energy, Princeton Plasma Physics Laboratory. So it's another type of paper, but in it we're literally computing the nuclear physics behind levitating plasmas in fusion reactors. And so here we display the results obviously, but anybody can go to this website, type the compute tab, and in here, people can essentially draw curves through parameter space, modify them. And every one of these yellow dots would essentially be a frame in that GIF that you just saw rendered on the front page, and recompute essentially how these fusion processes are occurring. And when you say go to the network, every single of these yellow dots gets sent off for computation in parallel. So in serial, this could take about 6 minutes per point. But if you do them all at the same time on different computers, well, the whole job would only be 6 minutes. Here's another one for COVID-19. This one's really cool because for the first time we exposed the ability for Canadians or people around the world to essentially crowdsource their power in order to help solve these problems. So on the research side, any researcher can hit the research page, and we have a nice little intro where it says, okay, this is a partially observed Markov process statistical model for predicting and matching historical data and going into the future and all this other stuff. And the model, instead of having some command line interface, researchers can literally just drag and drop their data. That's it. That's how clean it is. And when they want to run searches, for those of you who are a little bit more heavy into the theoretical stuff, this is actually going to do a hyperparameter search through a 12-dimensional space of parameters and fine-tune and essentially optimize the best fit for the model. I'm not going to run the compute here, but if I hit go, like if we computed 1,000 points, they're about 6 to 20 minutes per point on average. It would literally take one computer 34 days to run this compute. We know because we did it, but in parallel, it takes about 3.9 hours. And then in the refinements page, again, sort of drag and drop. Then you get like with Plotly, you can build in whatever your favorite JavaScript tools are in here. You know, fully interactive. Look at how the points fit with the uncertainty and all that other stuff. And finally, right here, this is data that we computed for measles. Actually, you can literally see the fit between statistical models. So behind the hood, it's just whatever JavaScript code you want to throw in there, and the historical data with the best fit. So now we can start doing things like, okay, well, what if we stop physical distancing? Or what if we introduce a vaccine campaign or something like that? And see how, and like predict into the future how policy can affect, you know, the number of cases. So these are cool applications that you can build. And normally you'd probably use AWS or something, right? Which would, I mean, it's free for the first, I don't know, couple of hours that you use it, but then they start charging you. And most companies spend between $100,000 a month up to $2 million a month. Netflix spends something like $40 million a month on AWS, to give you an idea of how expensive it is. But with this, you can literally run around a computer lab at your university and hook up, you know, 100 computers by opening a web page to join your compute network and then launch a bunch of jobs. So think about how creative you can be, right, in terms of being creating things that leverage like almost like a supercomputer at your fingertips. So that's what we've built, and we would love to have you build stuff. Ask us questions. I mean, we'll be on Discord all day, so we have some docs. I think those were shared. We gave you a key store. If you want your own, you go to portal.distributed.computer. You can create your own and earn some credits and deploy some work and go back and forth. In the next, like I said, in the next few weeks, we'll be releasing this. Like the full version is not finished yet, but we're getting there. Any questions? Ryan, can you take us through your fractal 3D rendering one with that uses the fancy tools in the back end to give people some more ideas?
Yeah, I can give a quick demo of that. First off, I'll show the end result. So I decided a few weeks ago just to play around with our system to extend upon my project from last year's TOHacks submission. And I built a 3D fractal renderer this time. So just my desktop. And this is what I ended up with. This is a rendering of the Mandelbox fractal. It's a 3D fractal that I use shaders to render it with ray marching. But you could render any shader, any computationally intensive. You can do WebGPU inside our workers. So anything that you want to do with shaders, you could run inside our. Can someone not hear? Oh, never mind. Anything you want to run in shaders, you can run on our platform. And to do that, I just took some shaders I found online, and I built a wrapper with DCP around it. To do that, I used some TypeScript. You can see we got our HTML template, same in the JS fiddles. And then I used DCP to wrap all my shader code as the work function. And then when you deploy it to the network, you can say that each worker will work on a tiny part of that big image. On one spot, you can break it up. And then the main node can assemble it all back together once you get the results back. So just as an example of the type of stuff you can do, it's not limited to just numbers. You can do graphics. Since we can do WebGL, you can also use TensorFlow in our workers, which we're currently experimenting in for some machine learning, some image recognition. Eventually, we want to be able to stream video into our workers. So you can make each slice be a frame. And as a video feed comes in, you could stream that frame to workers and get results back to analyze pedestrian traffic or find parking spots. Anything.
So Ryan, there's a question about writing in JavaScript. Everything has to be in JavaScript. So that's the easiest way to do it. However, you can do some fancy stuff to Webpack, some C and some other stuff, right?
Yeah, so you can write all your code in JavaScript, but anything that can be transpiled to WebAssembly, you can also run because you can run WebAssembly in Node.js and on the browser. So for example, you could compile C or C++ code with Mscripton to WebAssembly and run that in your browser as well. So you're not limited to JavaScript. You can use, I think, anything that can be compiled to LLVM, which is an intermediary language, can be then transpiled to WebAssembly. So you're really not limited in that sense. And you get close to native performance, which is really awesome.
Yeah, it'd be cool to see like a Python project somehow wrapped in something. I mean, there's probably like Python to C, and then you could probably do something with the C to bring it onto the, like it could get messy, but it'd kind of be cool to see like someone take some Python code and throw it over. Why? Because then that would be a tool for everyone else who has a bunch of Python code to be able to just run it. That'd be probably it would probably be complicated.
So my recommendation is get not only the bones to make broth or the stock, but also get the meat. So the first thing I do is take off the bones. Then we're going to take off the breasts and the thighs. Cut off both sides.
I don't
I'm
think,
not sure if that's a
yeah, I
question.
don't think that's for us. So yeah, everyone's so quiet here. I'd love to hear from
Okay, I just joined the call.
Howdy. So yeah, we'd love to hear from you guys. Like anyone, unmute yourselves and speak up and ask us any questions.
I see one from Andy. He's asking if there's code in the field of aviation.
Oh, absolutely. Is there ever? I mean, the code that runs an F-18, there's like millions of lines of code, but you have to be a little bit more specific by what you mean by aviation because it's huge, right? So, for example, the code that goes into finite element analysis to actually simulate the stresses and strains on aeronautical components while they're undergoing stresses, whether flying or whatnot, is huge. And that's actually, I mean, there's a multi-billion-dollar idea, well, maybe not billion, but multi-million-dollar idea right there is to write like a finite element analysis application to model computational fluid dynamics to run simulations on aircraft parts. Right? That would be cool. Well, that'd be like, you know, you could build a company around that using DCP, for example. So I don't know if that's what you meant by aviation, but you could do a lot.
If two good questions here from Matt and Sean. Matt had a question: how do you prevent bad actors from returning boggled compute data? That is a really interesting field. This is where we get into building consensus networks. So instead of handing out one slice to just one computer, you could also say, I want to run this slice on two computers at once and just compare the results. If they don't equal each other, then run it again on a third party. Or you could say, I'm pretty confident that the workers will be good, so maybe just run 20% of my work on two computers. And then you're guaranteed with at least some level of certainty that your work is correct. So it's there's a balance between how much you're willing to pay versus how confident you want to be with your results being right. But for the most part, once you find out a worker is bad, you just ban them from the network, and then you can be pretty confident that your workers are going to behave.
Yeah, and there's more. There's also like we're pretty soon we're going to be building again. This is why this is sort of like minimum. We're not the full product yet, but people will be slowly over time accumulating reputation points. So at first, when you join, you're anonymous. You're the network doesn't know you. But over time, once you've done a lot of work for a lot of projects and you've been consistently returning good results, your score goes up. And then on the on the client side, people will eventually be able to specify, I only want my work to run on a reputation this or above, right? But because of that, then they pay a little bit of a premium for that higher reputation. So now there's an incentive for people who join the network to gain higher reputation and not mess with it, because if they have higher reputation, they can access the higher paying jobs. So it's we're building a pyramid of trust out of initially anonymous, untrusted nodes by keeping track of good work. Bad actors, we can ban them, and so on and so forth. And the whole idea is to decentralize this over time. Now, there's another good scheduler question. How many people can you handle all at once? Right now, with the current scheduler, which is we're essentially about to completely upfit it over the course of the next 3 months. So it's going to be able to handle a lot more. But theoretically, what's the max number of connections and sockets? That I think it's something like 83,000. I don't know. I might be mistaken on that number, but it's a lot. But you can also do round robin connections and handle like, theoretically, depending on how long they're connected for. If it's just a couple of seconds per socket, and then you go to the next one, you could probably handle, I don't know, 1 million or 2 people simultaneously if you load balance it properly. But it only costs us about $800 a month to handle like 1 million or 2 million people. So scaling this is going to be, so cheap. It's going to be great. What stops people from just mining Bitcoin or other crypto? Well, that's a great question. So what stops, so that's from Kevin G. Kevin, unmute yourself, and I want to hear your answer why people are not using AWS to mine Bitcoin right now.
Because AWS is insanely expensive.
So you're completely right. So the value of distributed computing as a business activity is worth far more than Bitcoin. That's why our company never got involved in cryptocurrency. The value of actually distributing computations to advance like STEM research and like cool business ideas and build stuff is worth so much more than some coin. That's why. So on our network, people could write applications to go mine Bitcoin, but I think that the people out there building really intelligent things, they'll see that the price or the value of compute will rise to a point where it'll flush out useless. I shouldn't say useless. I should be careful here, but the network will generate true value. And if all this network is used for is mining cryptocurrency, then we haven't done our job right. We're disrupting innovation. So that's sort of like a long-winded answer to your question. Sure, people could do that, but the more they do it, the more it's going to raise the price, and eventually it'll sort of like wash itself out. Oh, Sidhu had an answer. Sidhu, you said you have an answer? Love to hear it. Oh, never mind. Can't have said it better myself. Okay, got it. I love these questions. Like, please fire away. We have a couple more minutes. No way. Okay. There's another question. Dan, can you elaborate more about the stuffs with the graph and the web you were talking about and showing? I like it. Okay. So you're talking about the graphing tools. Well, here's the good thing about JavaScript, and Ryan will be able to say this better than me. There's such a ton of already cool stuff out there on the web. Just pull it and build it into your project. Like if you just go to D3JS, you're going to see so many visualization tools, and it's open source, like bubble graphs and hierarchical edge bundling charts, and like here. Let me actually let's go for a spin on there right now. All right, D3JS. It's like grab any of this stuff for data visualization and just pull it right off and like put it in there. I don't even know what this does, but it's cool. One that I really like, let's see if I can find it. It's the, oh yeah, here it is. I think this is the one. Yeah, here's hierarchical edge bundling. So what we want to do, what you could do is just like, essentially it's a database that shows inflow and outflow, incoming and outgoing, could be connections or what have you. So eventually something I'd like to use our network for is to show sort of like credits coming into a person's account and credits going out of a person's account and how that sort of connects to the world. Right, so like we said earlier, we want to deploy DCP for free across universities and high schools across the country. So every computer lab, everything, everywhere will essentially turn into a giant connected supercomputer. But then you could sort of show how the chemistry department and the physics department are computing in a big network. So yeah, so you can grab this kind of code and just build it right into your own project, and boom, you're good to go. What determines the cost of a job aside from exec? Okay, that's a great question. So normally you can either like just leave the brackets empty, and that's default. And what that will do is it's going to throw your job on the network, but it will sort of pull the most recent value, if you will, for the value of computing. So it's kind of like automatic, so you don't have to think about it. But you can override that by essentially specifying a price per slice. So in Ryan's example, it was 0.001. So essentially 0.001 computing credit per slice would be paid to whoever's doing the work on the other side.
Button right there.
What else? Okay, what determines the price? So you can brute force determine the price that you're willing to pay per slice, or you can just let them, like the free floating market, determine what it is. So the more demand there is, the more the job price is going to be expensive. And then at night, when there's nobody connected, or sorry, there's less jobs, the price will go down. So it's literally like electricity. The other question, given that our theme is emerging technologies and participants can focus on COVID-19, do you have any ideas on how participants can implement DCP? I wouldn't even know where to stop talking about that. So here's an example of a little startup in Kingston. They actually took TensorFlow.js, right, in the back end. They're using DCP to distribute machine vision algorithms in order to measure the distancing between people in arbitrary video feeds. That's something. So now you can have municipalities and businesses verifying compliance, right, that people are properly socially distancing. And as long as people are behaving, then the city can remain open, or the restaurant can remain open, or something like that. So that could actually play an important role, post-opening, to make sure that people are actually following the laws. We could go on and on and on here. So what we're doing right now, we actually have a $2 million application into the digital supercluster, and it's in the final stages of approval. They are going to pay us and a consortium of 19 other companies that are working together to be able to do statistical modeling. The application I literally just showed you, we're going to turn into a platform that allows municipalities to forecast things like this. If we reopen in August instead of October, there will be 4% more infections, but we will save $15 million worth of economic activity, right? Versus opening in September, where you'll have 2% less cases, but you will have lost $4 million worth of economic activity. So it literally is a platform, it's a crystal ball, if you will, that allows municipalities to start thinking about like creating an actual strategy and knowing what the impacts are. And that's huge. Now we're going to license that all over the world, including the US and everything. So that's one application on top of this platform that can make a lot of money. Think about all your applications. And the most exciting thing that I haven't even touched yet is that, again, as we build this platform out, we're going to allow application developers to also take a cut of the compute credits that get deployed to run the job. So if you run an app that's really popular and gets used a lot, and people are obviously spending the credits to deploy it, normally we take a cut because we're scheduling and we built the whole thing, but we're going to allow app authors and library authors to take a cut in the future. It's kind of like Angry Birds. The authors, they built it. I think they're selling it for $1 on the Apple Store, and they got a penny for every download right off that dollar. And pretty soon they started making movies, and they're freaking rich. So we're going to enable that with DCP2 to share the value created by developers, library, application developers, all that stuff. Obviously the workers who are contributing their compute supply, and there'll be a whole bunch of layers of value add. What else? What's the business model? How does the company make money? So there are two companies. There's the nonprofit organization that's doing this for free with you guys and universities and everything else. And then there's our for-profit that's doing enterprise applications. There's a number of companies who are doing this. We're creating private networks on premises right now with a number of international companies and things like that. So everything that's not a school, so imagine medical research, imagine optical character recognition for banks. Like there's literally, like, there's no end to what you can do with computing. You could model better aerodynamic shapes for golf clubs. I mean, that's what Titleist does. They're not building a different golf club every time they want to test it. They run finite element analysis, much like they do for airplanes, to simulate, what the best optimal shapes and weight distributions are, right? And then once they find it via computer, they go and build it, and they manufacture it, and they sell it. So you could literally do anything. What else? There's a higher price because your job's higher priority. Absolutely. Absolutely. You got it. Sounds like a dystopia. What do you mean, Mark? Mark, I'd love to hear what you yeah, the thing with them monitoring people's locations. What who monitoring locations? Oh, post-pandemic. Oh yeah. So yeah, people who are doing contact tracing, that's monitoring people's locations. So we're not doing that. We're just taking, okay, if there were 11 cases in Kingston over the last little while, and then you pull demographic data that's already publicly available from StatsCan, you can actually run these predictive models. So it's using publicly available data completely. There's nothing personal about it. There's nothing that even needs to be anonymized because it's just public data, domain data in the first place. Can we boink on this network? So we took a project called Asteroids at Home, which is a Boink project, and we ported it over to our network, and we showed it to the Asteroids at Home project owner, and he fell off his chair. it is so much better because of again, it's just a web page. It's a clean interface. You can literally see the shapes of his asteroids, like that pop up. You can play with them. And we can do other cool stuff like, he only cares, so his name is Johan Durek out of Charles University in Prague in the Czech Republic. And he's essentially doing parameter fits on data that he's receiving. And Boink returns every single result of every single fit. And it literally fills up his hard drive and it crashes his computer systems because he's getting all results. He only wants the top 5% best fits, right? So Boink's not even equipped to do that. But since we've built this all from the complete ground up, I don't know if we're doing it yet, but we will soon. You'll be able to specify things like only return an answer that's better than the one I already have, and the rest discard it, right? So we have way more flexibility in terms of what we can do than Boink. We're benefiting from the fact that it's web tech, so there's a whole ton of tools already out there, and JavaScript, HTML, CSS, I mean, by a factor of 2, it's the biggest developer community in the world by far. I think there's something called Tesseract JS. It's a natural language processing toolbox or toolkit that exists. So you could literally like pull that in and then use DCP to run really cool stuff on I don't know, sentiment analysis and all kinds of stuff. I think AWS is charging like $3 per PDF that you feed it. I mean, you could do this on DCP for like a fraction of a penny, probably. Okay. Anyone else at Waterloo? No, that's not for us. How does this compare to a Boink project that's running natively? Okay, so in terms of performance, I'm assuming, Matt. So we took, so JavaScript's slower, absolutely, right, in itself. But we took some good C code, some good fast C code, and we ported it over, and it ran at half the speed of C. I mean, obviously it's context dependent and application specific, but in one that we're doing, literally the disease modeling one I was just showing you, it was running at nearly half the speed of C. But then you distribute it over 2,000 computers, and then it's 2,000 times faster. So there's a trade-off there. However, with WebAssembly, I think we can get pretty darn close to native language speeds anyway. So, and that's only today. I mean, Google, Apple, not Microsoft anymore, and Mozilla are working every single day to make their JavaScript engines faster and more secure. So we're literally standing on their shoulders. There's a tidal wave, right, already started and coming further, where everybody's trying to move to the browser. There's a project called Pyodide, where they're trying to take Python and make it run in browsers, right? So everybody is rushing. I mean, look at Zoom that we're using right now. There was no download, no install for this. It's literally just a link. I mean, it's in a browser. Google Docs, Google Sheets. Adobe's moving its engine over to JavaScript, right? When you want the new software, you hit refresh. You got the new software. So there's no patches and updates and download installs and stuff like that. And it runs on everything. I mean, how many devices can you think of that can't run a browser? I mean, iWatches now, you can literally open DCP on an iWatch and it will do compute. I ran compute on a Tesla a couple of weeks ago. Yeah. Oh, thanks. Google's Chromium team have actually flagged us a day ago because we're tracking some bugs of theirs because we're right on their tails integrating WebGPU into our standalone application workers. Right. So right now we can access GPU resources through WebGL through browsers, but we're building the next cutting edge thing, which is WebGPU, into our standalone workers. So this is going to be big, and I'm really pumped to have you all on this call because you're literally getting a glimpse of what's going to rock this world. So what else? My calculator would struggle with that. That's hilarious. Could COVID modeling have been used to foresee and prevent infections in various areas? Absolutely. So this application we're building isn't just for COVID, but any future pandemics. Right now, tick-borne encephalitis is making a huge comeback in Europe. Scarlet fever is making a comeback in Beijing. So disease modeling applications like these, where it's like literally put your username and password on any browser and you can sign in and do like epidemiology, that's powerful, right? You're literally empowering everyone to be able to do stuff. An electron where the download install app or browsers too. Was trying WebGPU. Today we crashed Firefox nightly. Yeah, WebGPU is still pretty cutting edge, so it'll be improved over the next little while. What time is it? It's 2:42. I guess we still got tons of time, but I mean, we don't want to waste your time. I'm sure you want to get hacking. But if there are any other questions, I'm happy to continue answering them. Otherwise, you know, we have docs. I think we sent them around. You can create your own key stores if you don't want the one that we sent you. You can earn your own credits. You can walk into your school and set up a bunch of machines to go and get you some creds and burn a lot of electricity that your school's paying for. No, I shouldn't say that. I'm just kidding. I take all that back. But yeah, we're excited to build some cool stuff. I'm not seeing any other questions, so I think that's it. Well, all right then. If there are no more questions, thank you so very much for listening in. Go ahead and build. We're gonna again award with the judges. We're gonna award $500 cash prize for the coolest thing that's built on DCP. But yeah, if someone builds some Python sort of automatic transformation stuff that runs on DCP or whatever, that's kind of cool. If someone finds like some way to do finite element analysis modeling on DCP, that's cool. I mean, again, I'm not telling you to do this stuff. I mean, someone else is gonna do something cool that I haven't even imagined yet, and that's probably gonna win. So just do whatever you want, and we are very excited to see what you built. And report bugs. I guarantee you're gonna find bugs with our system. I guarantee it. So just tell us, because we want to make this better.
Quick question. Someone's asking for the key store password.
Oh yeah. So the key store password is hack me. All one word, all lowercase. Hack me. And if you can hack our bank and steal all the credits, that would be a pretty impressive bug to find too. And then we could handsomely reward you and fix our problems. All right, take care. Bye everyone.